तीन तीन चार प्रोजेक्ट हैं जो एक जैसे ही हैं. Okay, class. Good afternoon. So welcome to the last day of this summer school. So today we are going to cover two important topics, that is time series analysis and data generation for ML using modeling and simulation. So very first session will be taken by the Rudransh Bansal. So just click on the link and explore what exactly we are helping you out, what exactly we are going to cover today. Now next session will be based on data generation. So that will be taken by myself. There are some self-learning resources, so kindly explore them. Resource of the day, and there is a Kaggle competition after the end of this class. So that is based on time series. Okay, so usko hum launch karenge, and we will inform you. And finally, there will be a feedback floated after the class. So kindly fill the feedback. How to improve this summer school? What is your learning? And what are the new things that you want to add in this summer school? So वो form आपको please fill करना है. And for the certification collection, so Monday you can come to LP 108. Okay, and also we will provide you the certificates in e-certificate also. तो वो आज शाम तक या फिर in next 2-3 days वो आपको email पे आ जाएगा. And hard copy if you want to collect it, so please let me know. And if you want to rejoin the institute after 15-20 or let's suppose 1 month, तो आप तब भी collect कर सकते हो, उसमें कोई issue नहीं है. So let's start today's session. So Rudransh, kindly share your screen. Unmute yourself and just give your introduction and then start the session.
Okay, so enthusiastic welcome to every one of you. I am Rudransh. I'm currently in 4th year at Harvard, and I am also the ML engineer intern at IIT Madras. So today's session is about unveiling the power of time series analysis. Till now, you must have seen many models, and in ML and deep learning, you must have seen NLP. So today we'll deep dive into time series analysis and understand like what time series actually is. So what we learn in this session is what is time series? Where are we going to apply time series? It is not like we can apply it only on any data. You have to check if time series is even applicable on that data. And then we'll do some exploratory data analysis on time series. And then we'll check out some libraries and models. We'll also do some hands-on learning with 2 models, namely ARIMA and Prophet. And then we'll talk about future scope and some projects which can be made in time series. So this time series, in today's data-driven world, understanding and analyzing the time series data can provide valuable insights for decision-making in various domains. So the most important thing in ML is always data. You can apply different models, but the most important thing is to get the most accurate data according to your problem statement. So let's just visit some data. Like suppose you can see this data, you have got months and you've got a figure. Like this is champagne sales data in millions. So you can see for different months of the year, like in January 1964, in February 1964, you have got this data. So as you can see, this data is time dependent. It is not like any generic series of figures written in a column. It is dependent on time, and moreover so, like suppose you have got some data like this. You have got some value on the y-axis and some value on the x-axis. So if I want to get the value over here, is there any model which you have already studied which you can apply and get this value? One of the answers could be linear regression. You could get this data from linear regression. So could you get the next point, and so on. So what is the difference between time series analysis and linear regression? Because linear regression can also give you this answer. You can go on interpolating this for any number of values using linear regression also. And so on, there are different models. So what is the difference between simple ML models and a time series model? In linear regression, suppose you have any data, a simple column of data, let's suppose this column only. So these values are actually independent of each other. They don't impact each other. But as far as time series is concerned, the previous values will always impact the data. Let's suppose I want to predict the value at y t at an instance which is t plus 1. So this t plus 1 record may depend on y of at time t. It may depend on time t minus 1 also by some factor. It may depend on time t minus 2. So it can be a combination of all these three datas rather than being a simple independent data. The most easy example of time series would be your stock data or your sales data. Sales data and stock data is also affected by the values on the previous days. And of course, there are some seasonal components in data which we'll just look. Okay, so we'll talk about these terms in relation to time series. What are trends? What is seasonality, noise, and stationarity? So I've included various graphs in this PPT. So as to give you an actual learning of what actually is time series data, what is a trend, and what is seasonality in that data. Also, I would urge you to participate in this session, as I've also been on the other part of the screen, and I can tell you that this time series models can be applied at wide ranges all throughout different applications, and they can be very helpful to you in various hackathons at IITs and different companies. And they can also make your resume shine out, because this is a quite simple technique, and it has got a profound impact. So let's just look at this data. So this can be like some AC sales data. If I could say, if these values were in month, you could say. If these values put in month, one could say that the AC sales will vary because it will drop down when it's you can say winter season and will shoot up in the summer season. So you can see there is a component of seasonality in this data, as this data is repeating its pattern over regular intervals of time. So can be seen in various domains, like you can almost identify in various sales data. You can identify ice cream sales, you can identify this data in blanket sales. And so it could be identified. If you could, has any one of you seen this picture anywhere? Like this could resemble to you if we could remove this upward trend. This looks more like a heartbeat. So time series analysis can also be applied to your health data. If I know your previous records of health, like if I know your BP, if I know your, let's say your pulse rate, or if I know your diabetes value. So seeing the previous records, we can predict the future values, because those values are dependent on your previous records. As I just mentioned, it may be dependent on time, it may be dependent on time t, it may be dependent on time t minus 1 also. It can be dependent on like n values. And the dependency can vary. Like this could have a larger factor. Let's say this factor is A1. So it may be more influenced by time t, because this is just like, if I want to get your pulse rate just now, it will be more dependent on the pulse rate for just 5 seconds ago, as compared to pulse rate which was 5 years ago. So the data which is just, just past data, that is of a more crucial importance. So these models, they try to calculate and figure out these values and how many data points is it depending. This is called the number of lags which we are having actually in technical terms. So the lags are not just the difference between two consecutive values, but rather the difference between, let's say I am taking this NS12. So let's say difference between the first and the 12th value. So in this data, we can identify there is a seasonality. Seasonality is there for sure. And we can identify that there is an upward trend. Like this is not a stationary data, like a like most generally your heartbeat should be stationary. So it's not like a stationary data. It is more like having an upward trend. It's increasing with time. Of course, there must be some residual errors which might creep in, which we also include by this term. But in general, we can see there is an upward trend and we can see there is a seasonality, a cyclic pattern which is repeating over regular intervals of time. So this slide marks down the trend. We can see the trend is an increasing trend. Although these data point values, the averages values, they are micro. They have this variation, but we can see the trend that remains fixed. Also, as I said, if seeing this data just for the sole purpose of interpolation, suppose we get this kind of data. The first intuition that comes into our mind is to just apply linear regression, which is as simple as y equals to mx plus c. So that could give us these points. But if we actually understand linear regression, we have got points like this. Sorry, there are points. And then we try to best fit a line between these points. So of course, these points have an error range. So what will happen when you go on predicting these data for future values is that net value of the error is going to increase. So the value of error in your data will be ever increasing. Since it is not considering any value of the past records, it's not influenced by any past records, it gives the same weightage to your 5 seconds old data and the 5 years old data. So hence linear regression is not the best solution for this issue. So what we do is to forecast this data based on time, and that is called extrapolation. So we just talked about trend. We'll see more examples about it. We just talked about seasonality. We'll of course see more examples about it. And noise. The residue it was left was the noise and then the stationarity. So we'll come to stationarity. Okay, this is a simple example of time series data. The value, as you can see, goes on increasing. It has got some seasonality, not much. It has also got some, we can say, an upward trend. So you can see these examples of US GDP, you can say Indian GDP, any GDP or sales value or long periods of time will be dependent on time series. So with time series, what can we actually predict? With time series, we can predict health data. We can predict your BP. We can predict your heart rate. We can predict your blood glucose levels. We can predict the state of your health if we combine all these factors through a random forest model. We can predict sales. We can predict the number of people infected by any disease. And we can go on predicting any value which will be dependent on time. So this time series can be incorporated in various domains of models. Like suppose you have got some cancer related data and to help some cancer patients on a cancer based NGO, then you can use time series data to calculate the requirements which will be further seen in different regions. Itne region mein itni requirement badegi aane wale time mein. So using that, you can rearrange whatever things that you require at that point. Just say it does not create a problem. So this time series can easily be implemented. We can implement it through R. Here we will implement it through Python. And we can easily deploy these models through something as basic as Streamlit for the front end. We can use Fast API, we can use Django, we can use Flask for deploying these models. And we can make it very simple. We can use Jupyter Notebook, Anaconda, we could use Colab. So what are the specific features of time series data that we need to look for before applying time series? So as I said, these data cannot be independent of each other. So if this is a certain data at a certain time, this will be dependent on the previous records. It will not be completely independent. It will be dependent on 12 records, 20 records. It will be dependent on different records with varying degree. It may be dependent on with a high degree on certain record, with less degree on certain other record. But it has to be dependent on the other records. So we have seen the systematic component in time series, which we call trend. And we have seen this seasonal component, the cyclic patterns which we are seeing. So we have got this trend, which can be upward or downward, and we have got this seasonality, which is a cyclic pattern. And then we have got this irregular component, which is nothing but your noise or residual data, which might creep into. This PPT can also be found at the GitHub link. So, okay, so ordering. So what we mean by ordering over here? Let's suppose this is a January data, and after this of the same month, of the same year, sorry. Let's say it's the same year. So if this is January data, and here I'm incorporating the let's say April data, and after that I've got the March data. So this is not the correct order. So it is very necessary that your indexes are based on time. That is, your ordering is mattering, and they are sorted in an increasing order. Right? January, then March, and April. So it has to be sorted based on time because it depends on the previous value of time. And we have got a special class in, you can say, special data type in Python to deal with these values. That's called a datetime object. And this datetime object is just super easy to use, just like any other database, and you can just learn it within some minutes. So missing data. As I said, since let's say this T4 is your month number 4, April. So for April, the data will depend on the previous two values of February and March. Now, suppose those values are missing, then how can you calculate the value for April? So we cannot have missing values. So one way of filling these missing values could be just a simple mean imputation. We could take out the mean of some neighboring values or some previous values, and we can just impute that mean over here. Similarly, we can take out the median of the data, we can impute it with median. So any kind of imputation or interpolation can be done so as to fill these values. Any kind of imputation or interpolation can be done so that we can fill these values so that we don't have any null values, because with missing data, we cannot predict the future value. So here you can see one example. Let me just clear the screen. So the first value, this is your data. So as you can see, there is a seasonal pattern in this data. So when we break down the data into seasonality, so this is how the seasonality of the data looks like. It is just resembling the seasonal pattern. You can see there is no as such trend here. It looks like going up, then it looks like going down. So there is no a particular trend in this data. Of course, there's a seasonality component in this data, and these are just some residual components. So this is how visually we can break down any time series to understand the trend and the seasonality in the data. So let's look at this decomposed visualization. As you can see, this observation over here, it's increasing over time. So we can clearly see there's an upward trend, which is indicated by this diagram, an upward trend. And the seasonality component. So if you remove the seasonal, if you remove this trend component, we can see the seasonality. It remains more like stationary. The mean remains stationary with this seasonality, right? So just like in simple ML, you have models like linear regression, multiple linear regression. In time series also, you've got different models. You've got long short-term memory, LSTM. You've got ARIMA. You've got SARIMAX. Now, initially, these terms might look like, okay, these are some huge terms, SARIMAX, this, that. But when you will begin to use it, these are quite easy terms, and you can just easily deploy these models. And trust me when I say that they have got varied usage. You can use it in various hackathons, various events, and they will prove to be utterly beneficial to you. Now, after talking about those components of trend, seasonality, and noise, we have this one more component, which is stationarity. There are certain models in time series. We'll come to those models, don't worry. So there are certain models which require that your data should be stationary. What stationary means is, let's see these three examples which we have over here. As you can see, suppose this is the mean line. There is high standard deviation in this first graph. The standard deviation is quite high. So what certain models like ARIMA, if I take an example, ARIMA requires that the data should be stationary. So here we need zero standard deviation, you can say. So only when zero standard deviation is there, then there is this condition of stationarity. So that's the first condition. Now, if we come to the second graph, we can see that the values are not varying much. The values are not like this. So they are not varying much about the mean point. They're not varying much about the mean point. So we can say that the standard deviation is zero. But what about the mean? Now let's examine this section. So in this section, the mean is about here at the mean line. But if we check about this section, the mean is like somewhat here. So the mean value is changing, as you can see. So stationarity also requires that your value of the mean is also zero. So the value of standard deviation should be zero. The value of mean should be zero. Let's then check out this graph. So is standard deviation zero in this graph? It surely is, because about the mean point, the values are not like this. There is not a high deviation between those values. And also, if you divide it into different sections, the mean value remains the same, which is in this case about the x-axis. But there is seasonality. So what we require here is no cyclic pattern. So we require that there should be zero mean. We require that there should be a zero standard deviation, and there is no seasonality. Only then the data can be treated as being stationary. We just go to the previous slide. We have seen those components of, we have seen the component of trend. That can be an upward trend or it can be a downward trend. We have seen seasonality. We have seen noise, which is this residue, and we are seeing stationarity. Right? So what are the conditions for checking for stationarity? Like what are the ways through which we can check for stationarity? One is visually. What we just did over here in this slide was checking visually. We just check if the standard deviation is zero, the mean is zero, and there is no seasonality. Those three conditions for stationarity. We just check them visually. But in time series data, there may be certain graphs which goes anyways around. You cannot actually figure out a pattern. So you need something more, can say something more theory based, something which you can actually implement and check, rather than going for doing this manually or visually. As different people can have different opinions, that could be quite subjective. So we can apply global and local test. So what we did in this graph was applying a global and local test. We divided it into different parts, and we can see it as a whole. This particular test is actually based on null hypothesis and alternate hypothesis. And depending upon the p-value, we get to know. Depending upon the p-value, we get to know if the data is stationary or not. So let's say there is a record by t, and it depends on the previous record, just the previous record. So let's say it depends in a linear fashion, p naught plus beta naught plus beta 1 t, and there is an error component. So this is just the value of your next record, right? So let's say we take out the difference. So what I mean by difference over here So you can see these data values. So what we'll be doing here, let's suppose we'll take out the difference between these two values. Let's say it's something here, we'll write it here. Take out the difference between these two values, we'll write it here. Take out the difference between these two values and these two values. So initially we had 0 to 4, 5 records, and now we have got 4 records. But what these records are, they are actually differences. So what we ultimately find is although this data can go on increasing, but the differences may be stationary. Hence, we can apply time series on these differences rather than applying on the data itself. So if we find the difference with just the previous value, we say there is a lag of 1. Okay, and let's say we find the difference between this and this value. So here the lag is of 3. So here you'll get one value for this thing. You get one value for this thing. So for 5 values, it is reduced to 2 values because your lag is of 3. So initially for the first 3, there won't be any answer. So we'll apply time series on these values, the differences, rather than applying it on the whole data set. And after applying time series on the differences, what results we will get, we will just convert it back into the original time series, just like what we do in certain ML models. So what we can see here is I just took z of t, let's say new time series, as y of t, this time series minus the previous record. So when you subtract this with the previous records, the constants will get cancelled eventually. And what we are left with is this value, beta 1, which is just a constant, and the difference of these errors. Now, since these errors, they originate from the same function, they're actually some kind of constant only. So the mean of this new time series, zt, will be a constant, and the variance of this time series will also be a constant. So this is somehow we can achieve the stationarity condition, and this is what we call differencing. So this differencing can be used at various occasions. Also, I would like to point out the question which I asked, that can we apply linear regression in place of time series? It's a famous time series interview question and can become handy to you if you will be applying to any of the even some of the HFTs or any company which is in deep learning or time series analysis or the high frequency trading firms which actually have a good package. So this is like more of a standard interview question. How can you say that linear regression won't give you the correct answer? Time series will. So as I said, time series have got different models. I mentioned to you the ARIMA model. In this session, we'll be implementing ARIMA model in a very easy way. So this session is quite an initiated session. We will be implementing ARIMA and Prophet. Prophet is a Meta's model. Initially, it was called Facebook Prophet. So that was FB Prophet, the initial name. Today the name is Prophet. So we've got Prophet and ARIMA. We have these two models which we'll be implementing in a very basic fashion to just get you started with it. And after this session, if you will explore anything about time series analysis, not just after it, but if you will deploy and make projects out of it, it can come quite handy to you. And it has got wide range of application. As I told you, you can apply it on stocks, you can apply it on sales, you can apply it on health, you can apply it on weather. I participated in a hackathon of Government of Telangana and ASCOM. So there we had to implement it for 5 cities. The 5 cities of Telangana, we have to implement it for the AQI and for the temperature. So we'll talk about this ARIMA model. There are many more models, and the applicability depends upon the data. Like if you see some seasonal trend, it is better sometimes to go with the SARIMA model. Sometimes the exponential smoothing model goes well. So we'll explore some of the models. Yeah, so this is the result of the project which I was just talking about. These are the names of the cities of Telangana state. So we can see for different models, the mean percentage error was different. Sometimes uh, these are similar data. These cities are quite nearby, but still here XGBoost model is giving the best result. For this city, profit model is giving the best result. For this city, profit model gives the best result. So different models can give you different results, and their applicability depends upon what kind of data you actually have. Just a minute. So now we'll be exploring a library which is called TSAI. It's the time series AI library which has got some inbuilt models. So you don't have to give each and every value for that model. Rather than you can just call these models. Functions are already made. You just need to call these models and execute them. Also, one topic that I had to talk about is the different types of data which you can have in time series. So it is not just limited to forecasting different values. Uh, we could use it in regression. We could use in combination with transformers, in combinations with classification. So let me give you an example of, let's say there is a weight, height, and based on that, we can predict whether that person is slim, fit, or obese. So let's say this is it's 90. So we can say that person is obese. And have like this, you can have any data. I'm just taking some random data value points to tell you about how these data may vary with respect to each other. So what happens is, let's suppose I'm taking, okay, let's see a data. It's called univariate. So let's say we have univariate data, and that's depending only upon the weight. So what happens? Let's say I have some more records, 60, and for 60, I know okay, the person is 10. For 70, I know okay, fit. So in univariate data, what I say is depending upon these values only, depending only on the weight values. Let's say you give me weight and height, but depending only on the weight value, say weight is 40. So I'll say, okay, this region, let's say these are the three regions. Better to mark them on the x-axis, but let's say these are the three regions. This is the slim, this is fit, slim, this is fit, and this is obese. So let's say these are the three regions. So you give me a value 40, and depending on 40, I'll tell, okay, this lies over here, so it must be in slim. You give me a value 100, so I'll say, okay, 100 lies over here, 100 is obese. So using these univariate data, we could predict, we could do a classification. So we can just apply time series on this part for weight, and using them, we can get these labels, classification. So time series is something in classification. But the thing is, it may happen that some points are overlapping. Some points, because of the other attributes, height, let's say suppose 1, 2, 3 or more attributes are there. So because of them, these points will be overlapping. So for some cases, univariate data, univariate classification can work. So what I'm saying is univariate. Also feel free to interrupt me if you don't get anything. So this is univariate. Now we can have bivariate data. So what is bivariate? Now, bivariate is something which we have been doing. We can have the height, we can have the weight, and depending on the height and the weight, we can have some clusters. For data values here, there's some data, there's some point over here, there's some point over here. So we know that if it's less on the weight here, it will be slim. If it's in the middle of the weight and the height, that will be fit. Here it can be obese. So again, here can be the same problem of overlapping. So then we can move to multivariate data. So univariate, multivariate, and bivariate, that just depends upon the kind of data that you actually have. So the slide, if that is open, we'll go to the TSI library. Okay. So this is the time series AI library, the state of the art deep learning applied to time series data. So we have got this TSI library over here. It is made by Alfonso Oguiza, like it is named by. So this library is quite easy to use. You just have to do pip install TSAI and you will get this library. Or whether you are on Colab or Anaconda or Jupyter Notebook, can be used on any editor. It's platform independent. Or you can clone it from GitHub. You can contribute to this library yourself, and you can become a contributor. So these are some of the available models. You can see the LSTM model, long short-term memory. Some of you might be acquainted to this model. The GRU model. This is, as you can see, a combination of two models and so on. So generally, you can get a work done by simple models, but if you want more accuracy, you can go with combination of models, just like you go with the random forest, just like you go with ensembling. Similarly, we can use a combination of models to get an answer, to get a result. So getting started with the TSAI, you can open this notebook if you want to get started with the TSAI, and it will first let you import all the different functionalities which you have in this notebook. You can see for binary univariate classification. So univariate means it depends on one data, as the example we took. We took the example about weight. So you've got weight 40, 50, 60, 70, 100, these values. And binary classification means there can be two labels to it. It can be fit, not fit, not fit, so on. So here it applies on ECG data. So what this TSI library also has is a large number of data sets. So this is ECG data on which you can apply your model. You are applying an inception time plus model, a simple time series classification, and we're exporting the pickle file. And here we are generating the predictions. We're just loading the pickle file in the load learner, and we are generating the answers. So as simple as that. Just these few lines of code can get you a result. But all these complex models, which you would have find harder to implement by yourself, like more lines of code. So similarly for multi-class, multivariate classification. So you can have height, you can have date, you can have gender, you can have age, you can have all these values, multiple variables, multiple columns actually, attributes on which your value is depending, and then you can have multiple classes, not restricted to 2 or 3 classes. You can have any number of classes. For that also, this works with equivalent number of code. You can see the same value of code as it was working for binary univariate classification. This is multivariate regression. It is not limited to classification, as I said, and we have some models which will actually work in combination with transformers also. Also, they have prepared, they have prepared an API. You just need to call the API and it will give you the prediction result. As simple as that. It cannot get more simpler. So you can see they have got 128 univariate classification datasets, multivariate datasets, regression. This is what we are primarily doing. Forecasting datasets. We have long-term forecasting. Let's suppose you have sales data. So what you will be more engaged in is long-term forecasting. You need data about 10 years, 15 years, so that you can predict what will the value tomorrow. So it is not as simple as that. Tomorrow you want to apply in the stock market. So you will just learn from this workshop some ARIMA models. You'll apply ARIMA model in the Tesla stock data. You'll get some values, and based on that, you'll make your investment. So it is not as simple as that. Please don't go investing by just learning from here. So do high frequency trading firms, do the Wall Street use these models? Yes, but not as simple as they have developed their own models in combination with different deep learning approaches. And of course, they keep it a secret. That's limited to their organization. And they use those models to get the results. So it's based on this concept, but minimalistically. They have worked hard on this with quite research, and then they have come up with those models through which they get those accurate results. Uh, so you can just check with this introduction to time series classification. Just open it. This is available on GitHub. I have included this link on my GitHub also. So no need to go looking for it. You can just type TSAI to get this library. You can see we're just importing the data. Fast AI, fast core. Okay. This is the list of all those data sets which they're having. We'll be using one of these data sets. They are using any tops data sets. Splitting the data into train test. They're visualizing the data. So if I could show you the results, what the results look like. This can be a better visualization. I can show you my own data sets. So let's have a look. This is an ARIMA model, and you can see after fitting this forecast, you can see this blue line. This is open, and this orange is the forecast. Open is the value of the stock when the stock market just starts for the day. So you can see this blue line indicates the value of the stock, and this orange line or yellow line, this is indicating the forecast. So this is after training and forecasting on the previous values of the data. It's good visualization. Just look. So you can see how the data is increasing with time. You can see the trend margins. These black dots are actually the averages. You can see the moving averages. This is the upper value of the trend, the light blue portion, and this is the lower value of the trend. Okay, so here we'll see good visualization of the data. So this is the data as is. We have just plotted the data. So you can see there is of course a component of seasonality, and there is some trend, not a good one, but there is some trend. It is increasing quite slowly, and of course there is some seasonality associated with it. So we are just doing this last part, understanding something about time series. Then we'll move to hands-on learning when we run two models, the ARIMA model and the profit model. So this was the Dickey Puller test which I was talking about. This is about this notebook is on ARIMA. So we will first do change this data to stage time. So how can we change it to stage time? I told you we have got three approaches. We can either do that visually by seeing it. Then we can do it through the global and local test, and then we can do it through Dickey Fuller test. So here we are implementing the Dickey Fuller test. So you can see the Dickey Fuller test, which I just told you, has got Nothing but it's just a function call, as simple as a function call. So you've got ADF test statistic, p-value, lags used, and number of observations. So you've got these 4 records, and what we'll be using is result one. Result one is your p-value. So what we're using is the p-value. If the p-value is less than 0.05, then we reject the null hypothesis, and we can say that data is stationary. Otherwise, there is weak evidence against the null hypothesis and data is non-stationary. So we are not diving deep into this p value and hypothesis. It is most important PNS, probability and statistics. Okay, so after we just checked on DF sales, the sales record. We just applied this Dickey-Fuller test for stationarity, and we find out that the data is non-stationary. So if the data is non-stationary, what we did in our PPT, when we found the data was non-stationary, is we calculate the difference. What we did over here is to calculate the difference. That's differencing. So what we'll do as a solution to this problem is differencing. So we are, as you can see, we are calculating the sales first difference. Sales minus DF sales dot shift 1. So you can, here we are calculating first difference. So you can calculate difference with the 12th value. You can calculate difference with the 13th value, any value which you do. So as you can see, this first value is missing. Why? Because for this value, there is no value above it to get the difference. Right? That's why this value is missing. So here we just shifted those records by 1. Okay. And then we'll subtract these values from the original values. And what we get after subtraction is this sales first difference. So we just subtracted these. So for this month, the first difference will be this thing, minus 143. When you subtract these two values, you get when you subtract these two values, you get 83. You subtract these two values, you get minus 34, and so on. So when we plot the sales first difference, so visually we can see whether it's stationary or not, or global local test, or the third thing was AD test, Dickey-Fuller. So now we'll check if it is stationary or not. If it is not stationary, we'll again take out a difference. If it is not stationary, we'll go on taking out the differences until the data is stationary. In most easy terms, this is how we do. So for this sales data, as I told you, this record is of champagne sales data. So how many months differencing is the best option that we should take? Anyone? So what differencing we are taking here is for 12 months. So why are we taking for 12 months? The reason lies is this is sales data. The same sales that is in January will be in the previous January, would have been in the more previous January. Let's suppose you take pollution in Delhi. So there are certain months in which the pollution in Delhi is maximum. Let's say October, or let's say December. The pollution is more. So it will be seasonal. It will be more like this pattern. Suppose there is this kind of pattern. So we are separating this out. We are saying, okay, this is one season. We'll match this data value with this data value. It will depend on this data value rather than October being dependent on previous year's January. It is more dependent on previous year's October. So that's why we carry out the differencing to make the data stationary so that we can apply certain models. And one of the models that requires stationary data is ARIM, autoregressive integrated moving average. It is quite clear with its definition also. We'll come back to this later. No issues. So after getting this seasonal first difference based upon your previous 12 months, we just check after dropping the null values, obviously, we'll just check if this is stationary. So we get yes, there's a strong evidence against null hypothesis. And the p-value is less than 0.05. So the data is stationary. Since the data is stationary, we can go ahead and implement our models. So as I said, it's an autoregressive model. So if you know, in the simplest of terms, regression is nothing but if we talk about simple linear regression, it is just beta naught plus beta 1 x, just like y equals to mx plus c, are constant values, and with some factor beta 1, it depends upon the independent variable t. This is how you get your y. So if you ignore these terms, what is written over here is I've got some value at t minus 1, and it depends by some factor in say beta 2 on, let's say, t minus 2, and so on. So this is just the function. So you can see this part is just a linear function. And after that, we have got some error factor, that error for time t. So it's a simple autoregressive model. So we know why we are calling it regressive, and it is changing its value for every next iteration. Let's say I want to get for 100. For 100, it is, you can say, let's take any example. It is y 9y99. I know my 9 doesn't look so good. 9y99, and we have got 5y98 and some error. Okay, so for next value, when I try to find for y101, it will be dependent upon 9 by 100. That is a value just one lower than the value for which we are searching, plus 5y99. So it is regression, and it is changing with every iteration automatically. So you can come to this. It's an auto-regressive model. So in this auto-regressive model, there are two terms which we'll actually study when we dive into ARIMA, and you can just contact me if you want, if you're more interested in it. They're autocorrelation and partial autocorrelation. Actually, what we need to find is three values, which we call by P, Q, and D, which were actually the lag values. D, which we just calculated, is differencing. So here, let's say we have a differencing of 12. P is for your autoregressive model, and Q is for your moving average. So actually, we take that index at which the difference is maximum. You can see the difference over here. The difference over here is maximum. So we'll take the index for which the difference is maximum. So for moving average and for this auto-regression, we have to see certain things, like when does it become stationary? Does it go on continuing like this or not? Based on that, we can have these order values. Or actually, you can play around with these order values, and you can test your data for some particular values. You test, and you can see where you have more accuracy. You can take those values. So it may work well with 101. It may work well with, let's say, 011. It um, it is not random. It depends on these two graphs and many more things. But you can play around these values because mostly the data which you'll be using won't require so much depth. Just a model fit function, and then we are generating a forecast. So you can see the forecast with ARIMA does not look good at all. This is your original data. This is your sales data. You can see, let's suppose this is AC sales. In summer, see it is spiking up. In winter, see it is going down. There must be some reason for this lower peaks also. This is actually champagne data. So maybe this is New Year. Maybe this New Year, this I don't know what's this period, the sales drops. So this is the sales data, and this is, you can see, the ARIMA forecast. So ARIMA is not working well for this model. It happens. Some models are not working well for certain kind of data, but there is a model very closely related to ARIMA, which is called SARIMAX. We take into account the 12-month seasonality, which also was talking about it. So this point, as I said, let's suppose this is 1 January, New Year, spike in champagne sales. So this is more dependent upon this point, right? So we take a 12-month seasonal difference. So we take into account the seasonality of the data with a greater perspective. So what model which we are employing over here is the Sarimax model. There is of course a Sarima model. There is a Sarimax model also. So here what we're including is this 12, which stands for the seasonal value. I am taking the 12 months difference. So just see the change in the average, which results for me. These are your, the blue line is for sales, and this yellow line you can see your forecast. So just see how your forecast moves so much closely with your sales data. And if we go on forecasting, I think if you go on forecasting, the next values will also go on resembling the previous trends. They will have an upward trend and they will have a seasonality. So yeah, this is a forecast. And you can see these are just two lines code, just 2-3 lines of code. You are able to get a forecast on a crucial sales data. So using forecasts such as these could be extremely beneficial to any organization. So as to work for future plans. So you can see how closely this forecast resembles its parents' data. And you can, if you marginally look out, there is an upward trend still visible. It might be going down because of COVID, and you see the sales are going up again. So if it goes on predicting, it will predict these values. And as I was talking about stock data, that you cannot just go on and apply on Tesla stock, you'll apply this model, get some value, and then invest. So if you take into combination, let's say the news, you can take into combination the NLP on sentimental analysis of the prevalent news of the market and the stocks. If you take this time series, if you take many of the models, assemble everything together, you take some approaches which in technical terms is called quantitative finance or quantitative modeling. With all that backing up in mathematics, when you come up with a model, it can actually tell you what will be the price of Tesla stock tomorrow. And some companies are working on it. There's a company, JPMC, JP Morgan Chase, which is working on the project called Index GPT. So just like ChatGPT, it will be able to, like ChatGPT is an AI tool, you know what is ChatGPT. So Index GPT के साथ you will be able to get the value of that index or stock. Okay. So it's time for the hands-on learning session. And the links for the ARIMA model, the data set that we'll be using. With ARIMA, we have a Yahoo Finance data set. Okay. So the profit model and the data set we'll be using are available in the GitHub. All resources are. So this is the ARIMA model, the profit model, which we'll be implementing over here. And we'll be using this airline passenger CSV, this data set. Okay. So if my kernel is still running. So I have prepared this ARIMA model and it works on stock data. So I've on purpose, I've chosen the Tesla stock. So if you guys also want to join on running this notebook, you can download it. I'll wait a few seconds. If you want to, I'll wait a few minutes if you want to download that on your Jupyter notebook, and we can run it together. And if any error creeps in, you can just ping me. Let's begin with the ARIMA model, and then we'll move to the profit model. So, as I said, it's an auto-regressive integrated moving average. We would have come to the term moving average If I could show you over here, right? This is a 30 days rolling average. So if I talk about this point, till then you guys can download the Arima notebook. So if I talk about this point, its value is dependent upon the mean of the previous 30 days. You can see the previous 30 days. It will be somewhat over here on the previous 30 days. If I take this value, then it depends upon the previous 30 days. So this blue chart which we are having over here is the actual value, and this yellow line which you can see is 30-day moving average. That is average of the previous 30 days, as simple as that. So what it helps you in the curve smoothing. So when the curve is more smoothened, you know, if you remove these spikes, if you remove these noise, if the curve is more smoothened, we can have better results with our model. So if we remove these outliers, so one way could be this open this moving average, open 30 days rolling or any days rolling. Like on high, I have taken 20 days rolling. I'll share this notebook also in the GitHub itself. Okay, let's go with Arima. I think those of you who want to do it together, so download it. So these are some simple libraries. We just run it. And here I'm using Yahoo Finance. So initially what I was using is get data Yahoo. So from Yahoo Finance, for any stock, you just have to write the NASDAQ, which is the American Stock Exchange. You just have to write its uh, stock index over here, TSLA. For Microsoft, I think it is MSFT. Facebook, it's FP. It's Meta now, so it must have been META. For Google, also you can see the values. So you just need to put this value. You just need to install Y Finance, and in Y Finance you just have to do Y Finance dot download, and in brackets you just give this value. So what it gives you is the stock data set of any stock on which you want to employ this time series. I've already downloaded it, so I would download it again as it takes some time. Then we come to TF test. So just see, they've got open, high, low, close, adjusted close, volume, and forecast. Okay, right. So when the stock opens up at 9 a.m., let's say, it has got a certain value. When it closes on that day, it has got a certain value. And the highest value which is it achieves on that day, that is high. And the lowest value it gets on that day, that is low. And then we have some adjusted closed based upon the open. Those are all some, you can say, and the volume of the stocks which are there. Those are commerce terms. So we are more uh, oriented towards these four terms: open, high, close, close. So we can just take any one of them and we can apply a model on it to see how the results come out. See, if I would have used some sales data, you could have seen some really good visualizations, just like the notebook which I had shown you. So here we have taken a stock data. You can also take health data. So if you can understand the beneficiality of this process of time series models is that if you have got your health data, you can get your future data. Okay. Let's suppose a patient comes in ICU and we can get his future data. So just understand the importance of the data at that point. So that comes in with time series. Of course, it won't be as simple as just employing LSTM or ARIMA, just a simple model and getting the value, but it can be a very well future project. And actually, I'm working on such a project. So we can see this. This is simple pre-processing. We are just checking out if they're in null values. If so, what we'll do is implement, as I told you, any imputation. We can put the means over there or median over there, or we can have some interpolation so as to fix those values. This is the head, tail. That's we'll just drop the null values and you can see the info. Okay. So what we are doing over here, our Tesla data set, you can see this was the data set. It had date as its index. Some models can use date as date time object as the index. If we can see the type of it. Anyway. Okay. See here you have open, high, close forecast. You don't have date. So why don't you have date column? Because date is an index over here. So what we are doing over here is resetting the index. That will remove date as an index. So after this operation, date also becomes a column. And its type is date type object, date time object. Right? And this is your index now. What you can do is you can have reset index once again, and everything will shift again once. You can have more times reset index, or you can change the index by yourself. So yeah, df Tesla equals to df set index date. So this is just to show you, we don't require to do this in Arima. I'm just telling you how you can reset the index and how you can set the index to any index that you want. And then I'm just plotting the close over here. So you can see the Tesla stock, how it changes over time. There is lack of a substantial seasonality. There's an upward trend, but initially the trend is quite low. And then you can see there is quite a boom and then it goes down. So there is no fixed trend. There is no fixed seasonality, as you can say, but still we'll apply the data and check if we can get some inferences. So this is the decupolar test. As I told you, we are applying ARIMA model, and ARIMA can only be applied on data which is stationary. So for stationary, we can have three things. As I told you, we have got to check it visually, a local global test, and the decupolar test. So in the decupolar test, we have the p-value, result 1. Result is an array, and at index 1, we have got p-value. So if the p-value is less than 0.05, we reject the null hypothesis, and we say it is stationary. So when we applied it on open, we are predicting on open, we find that the data is non-stationary. So since the data is non-stationary, how are we going to make it stationary? We can find the differences. So here I'm using a very simple shift by one index. Now it may be seasonal data, it may be depending upon 12 months. On sales, we are sure that it will depend on 12 months. If you have your, let's say, blood glucose level, it will be dependent upon the past 24 hours, because breakfast will match with breakfast, lunch will match with lunch, so on. So here, just for experimental purpose, I have taken a shift of 1. So you can take a shift of 12 for seasonal data and when you are dealing with sales data. And I've just printed the first difference. So you can see these are the values of the first difference. And now we'll see, is the first difference stationary? Can we apply ARIMA to this? Yes, it comes out to be stationary. We can apply ARIMA to this. Okay. So when we are applying ARIMA, I told you there are 3 parameters, P, D, F. It is auto-regressive, integrated, moving average. So what we need is the lags in auto-regressive part. We need the differencing, and we need the number of lags in the moving average. Okay. We can go into further depth, but we have to cover some more topics. Okay. So we have this autocorrelation factor. We are plotting the autocorrelation factor, and we can say it goes down. This is the largest value by which it goes down. After which it just continues on. So we use ACF mostly for moving average part, and we use PACF for auto-regressive part. Now these things might seem like, from where does it originate? How do you know? So we can go into the depth of it. There is a particular theory for it, but since time limits us, we know that what you can understand from here is ACF will tell you Q and PACF will tell you P. And D is your differencing. So with what differencing have we tried? 1. If it is sales data, the best differencing is 12, if you're talking about in days. If it is health data, then again 24 hours. 1 would be best. So we just added date time and we inserted some values at the end for which we'll be predicting the the future data, right? So this is the ARIMA model. Here I'm applying with P, D, and Q as 6, 1, and 4. So this is 6, this is 1, and this is 4. Because when I tried it for 1, 2, 3, I tried it for various values. And if you look, you can also look it from this graph, where does the value decrease the most, and so on. We look at those techniques. So what we come to know is, you can see this orange line. You just run this graph because size 15 point per mind. That's a simple statement of plot for the size of this plot. Otherwise, it is quite compressed. You can see the orange line here represents the forecast, and the blue line is for open. So you can see how closely the orange line is overlapping with open. But since okay, then I've checked the same thing with Sarimax model, which we checked in that the previous notebook, and the PQD I'm taking here, PDQ I'm taking here is 1 on 1, and the seasonality component is included with 12 months. So let's see with that what happens. With that also, your forecast is following open quite closely. So it might happen that with the train data, you get a good result, but with test data, you don't actually get a good result, and your error increases. So one of the best parameter to get your error, which I just use in the Excel file, which I just showed you for different cities of Telangana, is the mean absolute percentage error. Percentage is the best criteria for checking the error in most cases, because absolute values can sometimes be misleading. Okay, so you can go on applying with ARIMA and Sarimax model. Now I'm showing the profit model, which is developed by Meta. It takes into accounts not only the seasonality in the trend, but also holidays. Let's suppose for the Black Friday sale, which happens in the US, they are predicting some data. For Diwali sale in India, a company wants to get the predictions. So the best model they'll be using may be profit. And in the Excel file which I showed you also, profit was giving you good results because it takes into account the trend, the seasonality, and the number of holidays. And even profit is not that good a model. It's quite easy to implement, but we have got models which are much higher advanced in profit. So you can come across to, you can deal with decimal values, point values in accuracy. You can come so close to the actual value if you select the correct model, especially from the TSI library, which has got many more models for you. So, and also something to get from here is Yahoo Finance. For more info about time series, you can definitely follow some resources, which I've also included in the README file. You can see Krishnak's time series playlist. It's a good playlist, and also AI engineering time series modeling and analysis. So these playlists and his GitHub also has got various models which he has gone to deployment with those models, and even I have used these models in various projects. So you can connect over to me and find some other models on my GitHub also. So now let's just check out this profit library. In a hackathon, in a previous hackathon, this profit library was giving me some errors. So you might find some differences with what you'll find on YouTube. The difference is, the problem is that those videos were made quite some time ago, and these models, they go on upgrading. Like sometimes it may not be compatible with your version of Pandas or Python. So that compatibility is also to be checked, and also the new versions are coming out. So also every profit is now changed to profit. That's the new library. So every profit is degraded. So this is how you can install it. Installing takes time, so I'm not running this button. you've got pandas data reader. You need pandas data reader, especially when you are accessing the Yahoo Finance data. So here I'm accessing this data, the airline passenger data. You've got month and you've got a value, nothing more. So as you can see, we have got a month and we have got a value. So just for ease of use, I've converted the month to DS, date stamp, and uh, thousands of passengers, the column which was initially in airline passengers CSV into Y. So what we'll be doing here is predict the value of Y. So this is your database, quite easy. This is your database. Okay. So what you can do is when deploying the models, you can have some IoT device, or you can have some sensor, or you can get this data from some API, or you can get the data from the database. Connect it through your ML model. ML model, you can just convert the ML model to a pickle file. You can run it on interfaces. If you have a complete interface, you can have Django. Or today there is a great tech which is fast API, quite easy to use, or you can use Flask. Connect your model with that database using these technologies, and the outputs. If you know nothing about front end, then too you can use Streamlit. Uh, it is quite easy to use front end tool, and you can make some figures and graphs, and those figures and graphs could be linked to your, even if you're using MERN, that can be linked to your MERN architecture. So this is how you can connect your time series model with your project. So here we calculate that, just describing the data set. This is just a simple EDA, exploratory data analysis, some pre-processing. We can also impute the missing values. This is the statement which I was talking about. Simple imputer. For the missing values, wherever you get null, we are putting in the mean. So in case there are missing values, you just put mean, right? Seaborn, we are just finding if there are any outliers. Also with Seaborn, as I talked you about, I told you about the multivariate data. So for multivariate data, Seaborn can be used to generate really good plots for visualization, which you can use. So yeah, I'm just finding some pointers. I've just commented this out to actually find the mean median of data. So as I told you, when you are actually using these time series models for some project, or you can say for getting stocks and stuff, so you cannot simply use a model that is same Marino. You need to find some inferences about it. What's the mean? What are the different quantiles? Where are maximum values lying? And so on. So using profit model is as simple as model equals to profit. Done. The profit model is called. Now you just need to fit your data frame on that model. These are the components which we have: yearly, additive terms, regression, and you can take into account the holidays. Here I'm not including the holidays, but you can also have the holidays into account. You can make some future data frames because your data frame, let's say it is limited to July 2023. So we can have it for the next, it is limited to 14 July 2023. So we can have it for the next 30 days. Okay. So the data which we have in airline passengers, that was going till, if we can see the tail of the data. Okay. That's quite a lot. Never mind. So that I think these values are the future values, right? We'll make the predictions. Just put the future dates in the model and call the predict function. As simple as that. And you'll get your prediction. You'll get a trend. You get the upper and the lower values of the trend, upper and lower values of the average, additive terms which we are having, yearly terms, multiplicative terms. So what it does, you have got a graph like this, and it breaks that graph down into a trend. There is a seasonality, there is a yearly into different plots to actually give you a good understanding of what's happening out there, right? So you can see this is how we plot the prediction, the actual value. So you just have to say model dot plot prediction and you plot down your prediction. Okay. You have got plotting the components. So you can see, as I was talking about, this is your trend. The data was like this, but your trend, as you can see, the trend goes like this. And and similarly, you can see yearly how the values change. On which date of the data the values are maximum. So once I was employing some news sentimental analysis, and I was checking how the sentimental analysis of the news was changing with time. So what I found out is during COVID and some stuff, you can find that the news is having a more of a negative perspective. So the negative value is increasing. So that would be visible from the graph. For the AQI graph, you can see the AQI would have decreased, negative sentiments in newspapers must have increased, and so on. So this yearly graph, the monthly graph, the trend, they can give you quite a many inferences about what's happening. And then you can have your prediction. So as simple as that for deploying the profit model and IE model. And you can go on exploring the TSI library to find more and more models for deployment. So we are mostly over with the session, and I just planned a small quiz. If you guys would like to participate in it, it has just 4 questions. If you want to know more about the ML models, you can find it at my GitHub. You can find it Krishnak's GitHub. It has got large number of models, and you can easily Google it around. Sometimes it might happen, as I told you, the model might have degraded. So you need to find the newer version, and you have to check its compatibility with the already installed libraries like Pandas, Python, so on. Okay, people are joining. I thought no one is joining. So please, this is the QR code. It's a short quiz of 4 questions, and it is entirely based on what we talked about in this session. And then the stage will be open for you to for any thing which you would like to contribute in the discussion. So we'll just start after another 1 minute. Okay, I guess we have reached the maximum. That's 19 people on the 30 people. Okay, so let's start the quiz. So you have 30 seconds to answer. I should have decreased the timing a little bit. No worries. Voted. Let's see. Okay, so as I told you, ARIMA model requires that your data should be stationary. That's why we were carrying out the differencing. For that, we had 3 tests, as I told you, the visualization, the global local test, and then you've got that Dickey-Fuller test with the p-value. The results are around 1. We have question 2. In the context of time series analysis, what is a lag? So the lag of the fundamental difference between linear regression and time series. Okay, let's go ahead. Nice. Okay. So I mentioned this in the discussion that let's suppose I want to get a time 100. So it is not the difference, the lag is not the difference between just the consecutive value, just the previous value. It can be difference between an observation and a previous observation. I told you we can take the 12th observation, observation number 88. Suppose you have the December data, when the cold weather is at its peak, the fog is at its peak. So I want to predict fog. So for December data, I'll take the previous year's December data. So lag is period between an observation and the previous value. Sorry if you had any confusions about it. Okay. Okay, so we are quite balanced. Question 3. Let's see. It may be 10 seconds. What is seasonality in context of time series analysis? It is 15-second time. We talked about the components of time series. We talked about okay, first you guys take it. Yeah. It's great. Many people got this correct. So we talked about trend, seasonality, stationarity, and noise, the 4 components of time series. Okay, the last question. Everyone is ready? Okay. What is the primary goal of time series forecast? So this is a like bonus question. I don't know why it has such a big time. Let's see the results. Yeah. We find the optimal parameters. It's not completely wrong, but to predict the future values. Our aim remains to predict the future values. The same way we also identify the historical patterns, but to predict the future value. Okay, that's good. So if anyone wants to unmute themselves and contribute anything to the discussion or have any doubts, then you are welcome.
Yes, class. Any question, query, please? Okay, no issues. Okay, Rudransh, thank you very much. Thank you for the nice presentation.
Thank you so much.
And I hope everybody loves the session. And class, one quick request. जो भी हमने आपको playlist दी है and TSA library के बारे में आपको बताया है, please make sure you should practice it. ठीक है, रुद्रांश ने time series almost I think from last 9th year, 9 months से काम कर रहे हो तुम?
Yes, sir.
So from 9th month he worked on time series analysis and he participated in several hackathons and competitions. So काफी he got good amount of experiences. So class, if you face any issue regarding the time series, you can contact to Rudransh. Okay. And so Rudransh, thank you very much.
Thank you, sir. Thank you, class.
Okay. Okay, class. Now let's have a quick 10-minute break only. Okay, because the next session is quite important for you, how to generate our own data set. Okay, so let's have a quick 10-minute break and then reassemble at 8 मिनट का रखते हैं, ठीक है, 4:50 पे रीअसेंबल होते हैं. Okay, class. Welcome back. So now second part is data generation for machine learning using modeling and simulation. So class, there is a link. Just click on this link. So it will redirect to my GitHub page. Open the link. So there is a PPT. Just click on the link. So those who joined late, kindly click on the link and it will redirect you to my GitHub page. And there's a link of the PPT. Open करिए इसको. Okay, so let's start. So class, everybody know about the basic idea of machine learning. We have the data set, we need to build a model, and that model will help us to predict for the new data, new input data sets. Okay, this picture is already clear to you. Okay, we already covered this set. We have the data type of, let's suppose 4 inputs are there, 1 output is there. And this is a linear model, and linear model is nothing but a type of equation. Equation में data डालो, and then we will get the input, we will get the output. Okay, so this is a thing that we already covered in our machine learning session. Now, similarly, if your data is model is of decision tree based, in decision tree based, first we need to build a tree. So that can be binary search tree or any other tree. So if new data will come, then it will take the decision according to the nodes, and then finally it will give either 0 or 1. So this thing you already know it. Now, one important question about what is the difference between machine learning and a deep learning. Okay, so class, in machine learning, we need to extract the feature manually. Then we need to apply some classification model, and after that, that model will able to predict your object kya hai. But in the deep learning, we need to give the data in the format of images, audio, video, that's it only. And there is no need to extract the features. It automatically draw the patterns and find out the hidden patterns in the data sets, and then it automatically train it. Okay, but the only one difference is that, machine learning required a small amount of computation, but deep learning required huge computation is there. Okay, so if somebody asks you what is the difference between machine learning and deep learning, so you can draw you can tell the difference. In machine learning, we need to extract the feature manually, but in deep learning, ये जरूरत नहीं होती है, वो अपने आप कर लेता है. Similarly, hardware resources. Now, so there are important terms. What do you mean by structured, semi-structured, and unstructured data set? Okay, so let's suppose we are talking about unstructured data. So in that, no format is defined. Means let's suppose you stored 1,000 movies in one folder, and no category is defined which is the movie for kids, which is the movie for motivation, which is the movie for old age people. Oh, these type. हमने सब एक को dump एक ही folder में मार दिया. Similarly, 10,000 documents stored in a folder. You already downloaded multiple PDFs of books. ठीक है, और कुछ भी आपको मिलता है, आप एक folder में dump मार के रख देते हो. So no format is defined. Similarly, 500 images are stored in a folder. To me, that is an example of unstructured data. Similarly, next example is structured data. So in this structured data, we are storing, let's suppose take an example of storing the song, okay, audio file. So I'm stored every song like in defined format, means what is the ID, what is the language, what is the genre, how many number of singers are there, how many likes and dislikes on YouTube or any other platform, and then several property can be extracted over there. So in that case, that is a well-defined structure. So this is known as structured data. Our next term is known as semi-structured data. So in that, very little information is provided. Like you have 1,000 movie, but still you divided stored the 1,000 movies in 3 folders. कि भाई this is a 12 plus, 16 plus, 18 plus. Similarly, you have 10,000 document, but you stored in some format. कि first year का ये है, second year का ये है, third year का ये है, fourth year का ये. Similarly, 5,500 photos are there, and you stored in two folders. Like these are the photos of male, and these are the photo of female. Okay, so class, very little information is provided, so that is a semi-structured data. But still, in semi-structured, you need to extract the features. Now, so this is the format for machine learning. There are several inputs are there, and one target column is there. Means there are two types of data set. Either it is a supervised learning or unsupervised learning. So ये सब चीज़ आपको मालूम है. In supervised learning, the model is labeled, but in unsupervised learning, model no label is provided. Now, the biggest issue of hurdle machine learning में क्या है? The availability of structured data. Nowadays, lot of social media is there, like your WhatsApp is there, your Facebook is there. अब कितनों को कहाँ तक स्टोर करें? तो क्या करते हैं, कुछ अगर let's suppose you got some motivational lines written over there, तो बस उसका स्क्रीनशॉट लिया, हमने सेव कर लिया. अब वो सेव करेगा, कुछ टैग लिखा है, नहीं लगाया, तो वो भूल जाते हैं कि क्या टैग था वहाँ. तो स्टिल that is a very biggest issue कि अब structured data available नहीं है. But still, let's suppose if you want to create your own structured data, so in that case, data generation using simulation will help you. So simulation क्या होता है? I hope everybody know. It is executing a real world process in a controlled environment. So that is a simple simulation. Okay. Now let's take an example of a dam. Okay. Now let's suppose I give you a task कि now आपको dam के टूटने का simulation करना है. Okay, you just want to know the strength of a dam. कि क्या है? So in real life, it is not possible because nobody will allow you to break the dam. But in the simulation environment, you can break the dam multiple times. Okay, so for this, you need to know what are the parameters. So class, this is very, very important. कि parameter जो input data अपने को चाहिए. So parameter can be height of the wall, width of the wall, water quantity कितना है, quantity कितना है, quality of concrete use कितना है, water flow कितना है, number of gates कितने हैं, and many other property can be calculated. So very first step is you should know the number of parameters. Okay. Now next, this is an example of car crash. Let's suppose Tata or Mahindra, they declare कि one of my finest car is that कि गाड़ी किसी भी angle से crash हो जाए and the passenger will save. So to prove this theory, कितने वो crash करा सकते हैं यार? At least एक या दो, maximum तीन, because car की cost काफी ज़्यादा heavy रहती है, तो ज़्यादा से ज़्यादा वो अपने real life crashes नहीं करा सकते हैं. So but in that case, अगर if they are using simulation, तो simulation tool use कर रहे हैं, so in that case, number of experiments can be, n number of crashes can be there. Okay, so जो data collect होगा उसको हम चीजों को यहाँ पे अपने model में या अपने final product में embed कर सकते हैं. Next, I hope everybody make some chemical reaction in their class 11th or class 12. But all the experiments you perform in room temperature and room pressure. Okay, but let's suppose मैं आपको बोल रहा हूँ कि कोई chemical reaction है, आपको -40 डिग्री पे करना है, या फिर बहुत ज़्यादा pressure पे करना है, but you cannot do that. Okay, but इसी तरह let's suppose we have a simulation software, so वहाँ पर हम ये सब चीजें कर सकते हैं. Okay, now take an example. So what are you getting from this picture? Karthik, Prabmeet, Nishtha, ये पिक्चर से आप क्या देख पा रहे हैं?
सर मतलब जो पिक्चर ऐसे सर शूटिंग है तो जनरल तो वही है बेसिक.
हाँ, सिंपल शूटिंग है, वेरी गुड शूटिंग है. लेट्स सपोज इस पर्सन को शूट किया जा रहा है. ही इज द क्रिएटर ऑफ बुलेट प्रूफ जैकेट. ओके, so it is nothing but a testing of a bulletproof jacket. अब जिस बंदे ने वो bulletproof jacket बनाई है, तो यार उसी को पहना के हम टेस्ट कर रहे हैं. ठीक है, so this is all about the bulletproof jacket. But यार bulletproof jacket की भी costing हम कितनी कर सकते हैं? Because the cost for a one bulletproof jacket is nearly 2 लाख रुपीस. तो कितना हम टेस्टिंग करेंगे? यानी कि एक गोली 2 लाख रुपए हमारे गए. And whenever bulletproof jacket is tested, उसमें हम दोबारा इसको यूज नहीं करते हैं. एंड लेट्स सपोज वी टेस्टेड 10, अगर हमने 10 जैकेट्स भी टेस्ट किए तो यार हमारे 20 लाख रुपीस चले गए। ओके, तो नाउ इन दैट केस जो अपने को सिमुलेशन एंड सॉफ्टवेयर अपने को हेल्प करेंगे वो बहुत बहुत हेल्प करने वाले हैं। ओके, तो नाउ क्लास if you go to Google, just go to Google and search for this line, list of computer simulation softwares. Chaliye everyone, just Google it, list of computer simulation software, and you will find a Wikipedia page. Usko open kariye. Chaliye फटाफट, शाबाश, just go to Google and and search for link. So class, this is the list of simulation software, and the best part is that they are available in different domains. Okay, so these are the some softwares, जैसे आप काफी softwares आपको मालूम भी होंगे, NS2, NS3. So network simulator and network simulator 1, network simulator 2, network simulator 3. Okay, so this is a simulation tool that is highly used in net if you're working in in some networking relationship. Okay, similarly, OpenSim, this is one of the tool that is used for biomechanical modeling. Okay, and one more tool is there, ANSYS. Okay, so those who are from mechanical and civil or any other core branches, so they know ANSYS is there. Okay, similarly, AnyLogic is there. These are the some well-known tool. MATLAB is also there. Okay, and so this will give you a list of simulation software. Some softwares are free, but some are license-based, proprietary-based softwares are also there. Okay, now come back to the slide. So class, these are the different domains. Okay, let's suppose you are very much interested in astronomy. Okay, but you are not getting that data, so you can find out the some simulation software जो astronomy related काम करता है. Similarly, if you are working in molecular dynamics, we love dynamics में हम काम कर रहे हैं. Similarly, if you love chemical reactions, so there is a chemical kinetic software is there. Similarly, if you love physics, then 2D physics simulator, 3D physics simulator are there. Similarly, multiple simulation software are there. You just name the your hobbies, your area. So वो वहाँ पे हमारे पास simulation software available रहेगा. Now let's suppose we are talking about some smart cities. So in that case, transportation and environmental planning simulation softwares are also available. So class, let's अब हमने simulation software के बारे में पढ़ लिया है. Now अब उसको implement कैसे करना है, कैसे इसको use करना है. So let's suppose take an example, a dam. So dam नाम की कोई library है. It may be available in Java or Python or MATLAB or any other कोई library आपके पास available है. So first you need to install it. तो हमने पहले इसको install कर लिया, and then after that we are using in our program. So class, in that case, what happened? Let's suppose there is a function with the name sim, and that required 5 parameters. So let's suppose parameter are x1 to x5, and the best part is that every parameters must have some lower bound and upper bound. So let's suppose x1 का 10 and 20 के बीच में था. Similarly, x2 -1 and 1 के बीच में defined है. x5 is defined between 20 and 50. Okay. So now, अब exactly क्या करना है कि आपने सॉफ्टवेयर को इंस्टॉल किया, आपने कुछ स्टडी की है, and then you find out कि there are 5 parameters. Now, अब class, what I did here, I generate 5 random numbers. ठीक है, and every parameter is defined between some lower bound and upper bound जो already defined है. ये important चीज है. Okay, अब आपने क्या काम किया, एक set of parameter find out किए, and then उसको आप you just call a function. It takes some time, and finally it returns the strength. This is my one entry. Similarly, second entry के लिए, third entry, fourth entry. So by doing this way, I can generate 1,000, 10,000, 20,000 of data set. Agree? Yes, no? Class?
Yes.
Perfect, perfect. Now whenever I am playing with this simulation software, I got to know that कि अगर मेरा मॉडल, अगर मेरी स्ट्रेंथ 25 और उससे ज्यादा है, then dam is stable, and अगर 25 से कम है, dam is unstable. Then again I labeled again. अब मैंने क्या काम किया, अपने डेटा को बाइनरी क्लासिफिकेशन में कन्वर्ट कर लिया. Okay, so now if I want to know कि exact strength क्या है, so in that case that model will be of regression type. But I want to know कि हाँ भैया वो stable है या unstable है, so I can transform this data into binary classification. Okay, so class, if you have regression data set, then you can generate 2 research papers by using one regression and by transforming the regression data into classification part. Okay, so I hope इस सभी को clear हो गया कि we have some, पहले तो हमारे पास कोई सॉफ्टवेयर होना चाहिए, ठीक है, it may be available in the library form, कुछ उसका पैकेज होना चाहिए, then we need to identify कि कौन सा वो function है, then I need to identify कि what are the different parameters along with their lower bound and upper bound. बस ये 3 चीजें अपने को पता होनी चाहिए, so we can generate the data sets. Now second software is Cantera. So Cantera is nothing but a chemical kinetic package. So class, this is library, that is a Python library. One of my master students worked on this library. So now class, let's suppose this is a reaction, and so Cantera library को install किया हमने. So there are 2 parameters, temperature and pressure. Okay, now I want to know कि rate of reaction क्या है. Okay, so class, temperature -40 and 40 के बीच में defined है. Pressure is defined between 10 and 50. So now this is a chemical reaction, and I want to perform in different temperature, different pressure, and I want to know rate of reaction क्या रहेगा. So similarly, the same way, just generate the random values for temperature and pressure, pass to the function. It will take some time, make some simulation, and it will give you the rate of reaction, and just note it down. And इसको पूरा automation कर सकते हैं. Just run it this for 10,000 times or 20,000 times. The data set is generated. Okay. Now class, the next question may be asked कि भाई इसकी authenticity क्या है? Because these simulation software are well defined, written by based on some physics, some chemical reactions, and experts developed by some experts. So ये authenticity उनकी है, because तभी उसको they got published and they are available in the market. Now next software is OpenSim. So class, OpenSim is nothing but a simulation software for biomechanical modeling. तो बायोमैकेनिकल मॉडलिंग में क्या है, लेट्स सपोज मुझे किसी के चलने के पैटर्न को एनालाइज करना है. ओके, नाउ द टास्क इज दैट आई वांट टू बिल्ड असिस्टिव डिवाइस फॉर माय ओल्ड एज पीपल. ओके, जैसे अपनी दादी के लिए, नानी के लिए, दादा के लिए, नाना के लिए, उनको एक चलने में असिस्टिव डिवाइस में बनाना चाहता हूँ. तो आई वांट टू बिल्ड अ सिस्टम जो कि थाई पे पहन लीजिए आप उसको, जस्ट फोल्डेबल, एंड दैट डिवाइस विल हेल्प टू मूव माय लेग्स. गॉट इट? So now class, just take, उसके लिए हमें क्या चाहिए? So there is a library OpenSim. So there is a function that required 4 parameters, and 4 parameters में क्या है? Age, बंदे की age क्या है? What is the height? What is the weight? And at what speed मैं उसको चलाना चाहता हूँ? So you just see, age may be between 10 and 80, height may be 100 to 200 centimeters, weight may vary from 20 to 120 kgs, and speed 2 to 24 kilometer only, because उसको दौड़ाना नहीं है. I want to just make a assisted device जो उसको walk करने में help करे. That's it. Okay. So now class, just see here. So just assume कि now जो particular device में बनाने वाला हूँ, that produces 4 type of forces, F1, F2, F3, F4. Okay. So now अब मैंने क्या किया? What I did here, I generate a random set of parameters of all the 4 parameters, pass to this function, and then this function make some simulation. It may take some time, and it generated 4 type of forces कि जो मैं डिवाइस बना रहा हूँ उनकी पर्टिकुलर लोकेशन पे ये 4 forces मुझे अप्लाई करनी है, so that it can help me to move out. Okay, so in that case जो आउटकम निकल के आएगा, that is 4 values. Similarly, generate another set of values, pass to the function, and again it will generate 4 different forces. So similarly, you can just execute for 1,000 times, 2,000 times, 10,000 times. So my data set is ready. One. Got it? Number one. Now, number two, after collecting the data, so a new person will come. Let's suppose a कोई भी नया person आया है. ठीक है? I need to take all these values. Now, अब मेरे यहाँ पे 4 output है, तो I need to create 4 prediction models. Got it? Now, a 4 in जो मेरे input हैं, I just give all the 4 input to all the 4 models. अब 4 models ने different forces predict की है कि F1 की prediction क्या होगी, F2, F3, F4 for the new person. ठीक है? क्योंकि मुझे अब नए बंदे को पे उसको यूज करना है ना. Now, the best question is that, भाई अगर if simulator is available, then why to generate data and you use machine learning? Class, anyone? क्योंकि सिमुलेटर भी वही काम करेगा भाई, उसको इनपुट दो, इट विल जनरेट द आउटपुट. तो बताओ, मैं डेटा जनरेट करा रहा हूँ, फिर मैं उसको उससे मशीन लर्निंग मॉडल बिल्ड करा रहा हूँ, तो ऐसा क्यों करना चाहता हूँ? यस, एनीवन? कार्तिक, निशित, हर्षनूर?
सर मे बी बिकॉज अगर हम मशीन लर्निंग यूज कर रहे हैं तो जो हम कोई भी अगर मॉडल बनाएंगे उसको हम अपने हिसाब से ट्यूनिंग उसकी ट्रेनिंग कर सकते हैं इफ नीडेड.
अरे वो तो ठीक है, लेकिन ऑलरेडी थिंग्स अवेलेबल, सिमुलेशन भी वही काम कर रहा है, सिमुलेटर भी वही काम कर रहा है ना. उसको इनपुट दिया एंड मुझे आउटपुट मिल रहा है. मॉडल भी वही काम कर रहा है कि इनपुट दो एंड इट विल एबल टू मेक द प्रेडिक्शंस. द थिंग इज दैट दिस इज द आंसर. Because एक simulation, let's suppose you want to execute one simulation, it take a huge time. ठीक है? अब मान के चलो मुझे एंड जो सिमुलेशन है it may required 1 hour, 2 hour, even 1 day. 1 day भी लगता है एक सिमुलेशन में. एंड ये चीज आपने खुद फील की होगी whenever you work with the CNN architectures. तो एक इटरेशन में हमें कम से कम 4 से 5 मिनट भी लग जाते हैं कई बार. ओके, इसका आंसर क्या है? ध्यान से सुनना. टेक दिस एग्जांपल. अभी जो फर्स्ट बंदा है हमारा, अभी राइट नाउ उसकी स्पीड है 4 किलोमीटर. अब नाउ आफ्टर सम टाइम ही और शी वांट टू लोअर डाउन हिज स्पीड कि 4 किलोमीटर ज्यादा हो गया, मैं और स्लो चलना चाहता हूँ. तो देन इन दैट केस जो 4 है उसकी जगह मैंने 2 कर दिया है. तो एज आई चेंजेस द इनपुट, तो सिमुलेटर मेरे को नई वैल्यू निकाल के देगा. बट लेट्स सपोज मेरा सिमुलेटर मुझे आधा घंटे बाद मुझे रिजल्ट निकाल के देगा. Agree? But वहीं पे if my machine learning model will be there, so these type of forces can be predicted in almost real time. So that is the best part. इसको समझने की जरूरत है कि let's suppose if I change any one of the parameter, then the output will be changed. तो वही चीज अगर मैं सिमुलेटर से वो प्रिडिक्शन कर रहा हूँ, तब ऐसा नहीं है कि वो बंदा आधा घंटे वहीं पे खड़ा रहेगा. ठीक है, कि नई वैल्यू जब आएंगी तब मैं चल पाऊंगा. तो वहीं पे मैं if I am using machine learning model, I can predict the new forces in almost real time. So that's why this is very important कि अगर simulator use कर रहे हैं तो real time में मुझे कोई application बनानी है, तो in that case simulator will not help me. तो machine learning model मेरे को help करेगा. क्लास यहाँ तक समझ में आया है सभी को? Yes, no?
Yes, sir.
This is the most important thing यार. Now next part, take one case study. Audio genre classification. I also covered, I show you this in the research paper, how to write a research paper. वहाँ भी मैंने ये चीज डिस्कस की थी. So let's suppose there is a ZT-Zen audio data set that consists of 696 audio files हैं, and that is classified into 5 parts. 5 different type के genre हैं, and हर एक genre में करीब मेरे पास कुछ audio files हैं, करीब audio files हैं. Now there is a library with the name Librosa that is used to extract the features. ठीक है, so 193 features मुझे वो extract करके देंगे, and these are the major grouping of these जो features हैं. There is a one MFCC categories, so that consists of 40 features. Similarly, Chroma is there, वो 112 features. तो कुल मिला के जो Librosa library है, it will give me 193 features. तो कहने का मतलब क्या है कि let's suppose I have 5 type of genre audio and that audio file are stored in different folders. 5 folders में defined है. अब मैंने क्या काम किया, एक फोल्डर को रीड किया, आई जो भी फाइल ऑडियो फाइल है गिव टू द लिब्रोसा लाइब्रेरी. लिब्रोसा लाइब्रेरी का मतलब फंक्शन होगा, एंड इट कैलकुलेटेड 193 फीचर्स एंड उसको लेबल कर दिया कि भाई ये पॉप का है. सिमिलरली आई टुक सेकंड ऑडियो फाइल, उसके फीचर कैलकुलेट किए, उसको लेबल कर दिया पॉप का है क्योंकि वो पॉप नाम के डायरेक्टरी में सेव है. तो सिमिलरली आई क्रिएटेड दिस डेटा सेट, एंड इफ यू closely looked at it is nothing but a multi-class classification problem. Okay, अब data set ready हो गया है and just apply the classification model. Okay, so this is all about कि data कैसे create करना है. Recently in Kaggle hackathon there are multiple types of Kaggle experts. आप notebook expert हैं, आप क्या कहते हैं data set, if you contributed some data set, डेटा सेट आपने डोनेट किया है तो यू कैन बिकम अ डेटा सेट कैगल एक्सपर्ट बन सकते हैं. सिमिलरली आप कंपटीशन में पार्टिसिपेट किया है मल्टीपल कॉम्पिटिशंस में, देन यू कैन बिकम द मल्टीपल कंपटीशन कैगल एक्सपर्ट्स. ओके, सो क्लास by applying these way you can generate the data set and you can donate to the Kaggle. So this help you and increase your profile in Kaggle platform. So class, now what is the basic, थोड़ा आइडिया तो मैंने आपको दे दिया कि कैसे यूज करना है. नाउ लेट्स स्टार्ट द सम इम्प्लीमेंटेशन, कैसे करेंगे हम. तो क्लास वेरी फर्स्ट इज फाइंड अ सुटेबल टूल, लाइब्रेरी और पैकेज. फाइंड आउट करो, इट मे बी अवेलेबल इन सी, सी प्लस प्लस, पाइथन, मैटलैब, किसी भी चीज में है उसको करना है आपको. देन उसको इंस्टॉल करो एंड रन करो, एंड रन बाय यूजिंग सम उसकी जो क्या कहते हैं मैनुअल दी हुई है उसको यूज करिए. Then very important is study the different parameters. You need to explore कि भाई कौन कौन से पैरामीटर हैं and what are their lower limit and upper limit. And the last part, generate random set of parameter, pass to the simulator and record the value. तो कुल मिला के सीन क्या है कि very first is random number generate कैसे करते हैं. I hope everybody know कि random number generation कैसे किया जाता है. But still, let's take an example. Let's suppose there are 4 parameters, x1 to x4. And every parameter is defined between some lower bound and upper bound, and ये एक range है, and I need to generate 100 rows. अभी for the time being just 100 random number मुझे कैसे generate करने हैं और उसको मुझे file में store करना है. So how many you can write this program? Yes, no? Perfect. Okay. चलिए good. Now अब इसकी कोडिंग क्या रहेगी क्लास? If you want to implement in Python, then first import the random library. एक फाइल ओपन किया हमने, and then I just write the header x1 to x4. तो ये हमने लिख लिया पहले. After that I am starting a loop from till 100 iterations. अब now जो मेरे random parameters है x1 to x4, I call a random randint. तो x1 से x4 तक मैंने generate करा है. Then I write to the string %d उनको मैंने लिख दिया and just writing the s to the file. So it will run for 100 times, and after that when loop is over, close the file and just open the CSV. So you will find this type of data set. So I hope सभी को ये चीज क्लियर है कि कैसे रैंडम पैरामीटर जनरेट करने हैं. ठीक है. नाउ नेक्स्ट, जो पैरामीटर आपने जनरेट किए हैं उसी को आपको फंक्शन को पास करना है, उससे जो वैल्यू आएगी उसको नोट डाउन कर लेना है. तो जस्ट टेक, so let's suppose objective function is nothing but a simulation function, a function that takes some parameter and it is single or multiple values. Okay, multiple values means जैसे हमने open sim में देखा था, it return 4 values. So 4 forces it return. So find out the function, उसमें कुछ simulation software रहेगा, simulation की library रहेगी, and then return the value. So let's suppose class this is a function. You can easily code this function. तो यहाँ पे क्या है, समीशन हो रहा है किसका, xi के पैरामीटर का जिसका मॉड होना चाहिए. तो यहाँ पे समीशन हुआ. आफ्टर दैट देयर इज अ मल्टीप्लिकेशन आफ्टर द मॉड लेने के बाद, एंड लास्ट में दोनों को आपको सम करके भेज देना है. एंड रेंज क्या है? रेंज इज -10 and 10. तो क्लास यहाँ पे सबसे पहले लेट्स सपोज आई नीड टू फाइंड कि लिस्ट ऑफ पैरामीटर्स क्या हैं. तो x0 to x9. तो d मीन्स नंबर ऑफ पैरामीटर कितने हैं, डायमेंशन. तो 10 numbers are there. Okay, in that case you need to find the minimum. अब ना उसको कोड करने का तरीका क्या है? एक फंक्शन मैंने बनाया. तो दिस इज जस्ट अ पाइथन कोड. तो def is a function, function name. x is a list of numbers, list of parameter जो मैं पास कर रहा हूँ. और उसमें कितने नंबर होंगे? d. ठीक है, d मैंने ऊपर डिफाइन किया हुआ है. d कैन बी चेंज, 5 भी हो सकता है, 10 भी हो सकता है, 20 भी, 100 भी हो सकता है. तो टू स्टोरिंग द सम, s is sum, and for multiplication product I take p as 1. अब यहाँ पर मैंने सम निकाला है, आफ्टर दैट मैंने प्रोडक्ट निकाला है, एंड लास्ट में दोनों को रिटर्न कर दिया. यू कैन ऑल्सो मर्ज द बोथ कोड इनटू अ सिंगल लूप. तो ये हमने कोड कर लिया है. अब ना क्लास जस्ट इफ यू जस्ट सी, तो डायमेंशन 5 मीन्स नंबर ऑफ वेरिएबल आर 5. I created random set of parameters 4. I call the fitness function. Function को call किया and I got some values. So these value can be like जो भी function calculate करके मुझको देगा वो value मैं note down कर रहा हूँ. ठीक है. Now let's suppose there is a function x1 to x8 and every parameter is defined between some lower bound and upper bound. अब इसका मुझे data generate करना है. तो class first I need to because function is nothing but a summation of all the parameter. So this may be the function sum of x, यानी number of जितने parameter में देगा उन सबका sum हमें return कर दे. The next part is अब मुझे file में data generate करना है. So class what I did, I just open the file in writing mode. I just write the headers in the file. The very first column is my target, then several input parameters x1 to x8. एक लूप रन किया मैंने, एंड देन जितने भी पैरामीटर हैं सबका लोअर बाउंड अपर बाउंड में एक नंबर निकाला. आई कॉल द फिटनेस फंक्शन. अब जो वैल्यू मुझे रिटर्न करा के देगा उसको आई स्टोर्ड इन अ टारगेट वेरिएबल. देन आई ट्राई ऑल द वैल्यू टू अ स्ट्रिंग, एंड वो स्ट्रिंग को मैंने एक फाइल में लिख लिया. सो आई होप ये सभी को क्लियर है. क्लास यस नो? एंड इन लास्ट यू विल फाइंड दिस टाइप ऑफ आउटपुट. क्लास ये सभी को क्लियर है? यस नो?
Yes, sir.
Perfect. So this is a very important thing. Okay, now basically some people, those who are working in mechanical or civil, so they, let's suppose मुझे stress testing करनी है या destructive मुझे testing करनी है किसी brick की या कोई metal की या फिर किसी भी sheet की. So I have limited small amount of I can experiment, I can perform. Okay, but let's suppose अब मेरे पास कई बार केसेस आते हैं कि मेरे पास सिर्फ 20 एक्सपेरिमेंटल डेटा है, इस पे मशीन लर्निंग लगा दीजिए. तो दैट cannot be possible. Okay, so at least for applying the machine learning 50, 60 or 100 data can be there. तभी आप उसमें मशीन लर्निंग लग पाएगा, अदरवाइज इतने छोटे से डेटा सेट पे क्या करना है. Okay, now अब ना आई एम जस्ट गिविंग यू कि ओपन सिम को कैसे यूज करना है. तो दिस इज नथिंग, इट इज नॉट द एक्चुअल इम्प्लीमेंटेशन, बट दिस इज द हाइपोथेटिकल कोड कि कैसे हमें करना है. तो लेट्स सपोज ओपन सिम की कोई लाइब्रेरी है, उसको मैंने इंपोर्ट करा लिया. जस्ट क्रिएट वन फंक्शन दैट कैचेस सम इनपुट पैरामीटर्स, एंड उसको मैंने यहाँ पे opensim.sim नाम के कोई फंक्शन है उसमें पास किया. इट विल टेक सम टाइम बिकॉज सिमुलेशन इज देयर, एंड इट रिटर्न द फोर्सेस. ओके, तो आई होप ये सभी को समझ में आ रहा है. सिमिलरली अब मैंने क्या काम किया, दिस इज द वेरी सिंपल पार्ट, बट इतना सिंपल होता नहीं है बिकॉज मोस्ट ऑफ द सिमुलेशन सॉफ्टवेयर रिक्वायर सम कॉन्फ़िगरेशन फाइल, कि भाई कॉन्फ़िगरेशन फाइल में ही आपको चीजें लिख के देनी है तभी वो सिमुलेशन सॉफ्टवेयर रन होगा. ओके, सो इन दैट केस सिमुलेशन रिजल्ट इज सेव्ड इन अ फाइल. अब जो सिमुलेशन पार्ट है उसके जो कॉन्फ़िगरेशन फाइल आपने रन की है, तो जो पैरामीटर आपके जनरेट हो रहे हैं, यू नीड टू राइट दैट पर्टिकुलर सिमुलेशन फाइल, एंड जो हमारा रिजल्ट आ रहा है दैट इज आल्सो स्टोर्ड इन अ फाइल. So let's suppose you run this open simulation software, फंक्शन को कॉल किया, एंड उसने एक फोर्स नाम की फाइल में आंसर लिख रहा है वो. तो आई नीड टू रीड दैट पर्टिकुलर फाइल, उसमें से आई नीड टू एक्सट्रैक्ट माय वैल्यू, एंड देन उसको मुझे रिटर्न करना है. आर यू गेटिंग क्लास? ठीक है, कि सम सिमुलेशन सॉफ्टवेयर इज देयर। अब वो सिमुलेशन के बाद रिजल्ट को ऐसे सिंगल वेरिएबल में नहीं दे देते, दे स्टोर्ड इन सम फाइल। ठीक है, उसको सिमुलेशन खत्म होने के बाद जो भी वैल्यू फाइल में सेव करके रख देते हैं। देन आई नीड टू रीड दैट पर्टिकुलर फाइल, और उसको में से वैल्यू मुझे आई नीड टू एक्सट्रैक्ट द वैल्यूज ऑफ द पर्टिकुलर वैल्यू, जो भी पैरामीटर की वैल्यू मुझे चाहिए, देन उसको देन यू कैन रिटर्न दैट पर्टिकुलर। तो आई होप ये चीजें थोड़ी सी क्लियर हो रही हैं आपको। Similarly, let's suppose I talk about the Cantera. Cantera is nothing but a chemical simulation software. So अब Cantera को पहले इंस्टॉल कर लिया है मैंने। Cantera में let's suppose there is a sim नाम का कोई फंक्शन होगा। I pass the parameter and just it makes simulation and return the rate of reaction. Okay, so that can be also possible कि हम इसको ऐसे इस तरह से execute कर रहे हैं। Okay, because this is all about the particular part कि कैसे हमें काम करना है। ठीक है, तो यहाँ पे सभी को क्लियर है? यस नो? ओके, चलिए। Now class, there is a very quick and very important topic, how to call external commands. In external commands, what happen? Let's suppose किसी एक प्रोग्राम में आपने कोई प्रोग्रामिंग लैंग्वेज, यू आर यूजिंग वन प्रोग्रामिंग लैंग्वेज, बट पर्टिकुलर ऑपरेशन किसी दूसरी प्रोग्रामिंग लैंग्वेज में लिखा हुआ है। अब उस प्रोग्राम को मैं कैसे कॉल करूंगा? तो क्लास जस्ट आई एम जस्ट गिव यू अ सिमुलेशन। जैसे लेट्स सपोज इसको नहीं करते, पाइथन ही चलाते हैं। लेट्स सपोज पाइथन के थ्रू जस्ट सी हियर कैलकुलेटर कैसे ओपन करना है। ओके, लेट्स सपोज फर्स्ट आई एम इंपोर्टिंग os.system, there is a function file. अब I just write calc। तो आज तक आपने कैलकुलेटर जस्ट कमांड प्रॉम्प्ट पे राइट किया है, you never applied or never think to call a calculator through any programming language। तो जस्ट एंटर मारो, मेरा कैलकुलेटर ओपन हो गया है। ओके, so class this will help you in automation। ठीक है, सिमिलरली इफ यू वांट टू ओपन अ नोटबुक, नोटपैड आपको ओपन करना है, तो OS यानी कि पाइथन में लिखा .system एंड देन मेरा नोटपैड ओपन हो गया। ओके, तो नाउ क्लास जस्ट सी हियर, लेट्स सपोज मैं पाइथन में हूं एंड आई वांट टू कॉल सम प्रोग्राम। सिमिलरली लेट्स सपोज एक पाइथन प्रोग्राम है, आई वांट टू कॉल अनदर पाइथन प्रोग्राम। तो इस तरह से यू कैन कॉल अ डिफरेंट पाइथन प्रोग्राम। सिमिलरली you can call the R program also, C का प्रोग्राम, जावा का प्रोग्राम, इस तरह से कॉल कर सकते हैं आप। ओके, सिमिलरली लेट्स सपोज इफ यू आर वर्किंग इन R प्रोग्रामिंग लैंग्वेज कॉल कर रहे हैं, तो सिमिलरली यू कैन यूज अ फंक्शन सिंपल सिस्टम। वहां पे कोई लाइब्रेरी इंपोर्ट करने की जरूरत नहीं है, तो यू कैन ऑलरेडी यूज द फंक्शन सिस्टम। सिमिलरली इफ यू आर वर्किंग इन मैटलैब और ऑक्टेव, तब भी हमें कोई फंक्शन की जरूरत नहीं है। If you're still working in C, C++, Java, तब भी हमें कोई फंक्शन की जरूरत नहीं है। ओके, तो let's suppose you write some program in C or C++ or Java, but you need a specific plotting कि मुझे Python के थ्रू कोई प्लॉटिंग करनी है। तो क्या करो, Python का प्रोग्राम लिखो, C के थ्रू उसको कॉल कर लो, एंड जो रिजल्ट आएगा वो ऑटोमेटिकली एग्जीक्यूट हो जाएगा एंड स्टोर इन द फाइल। ठीक है, तो दिस विल हेल्प यू इन ऑटोमेशन प्रोसेस। ठीक है, नाउ आई एम जस्ट एक्सप्लेनिंग यू कि कोई ऑटोमेशन आपको कैसे करना है। प्लस टेक दिस एग्जांपल, अभी मैंने आपको टास्क दिया है कि भाई यू नीड टू डाउनलोड 100 इमेजेस ऑफ बाइक फ्रॉम गूगल इमेजेस से 100 बाइक डाउनलोड करनी है। देन यू नीड टू रीसाइज ऑल इमेजेस टू 50%। आफ्टर दैट उनको ग्रे स्केल में कन्वर्ट करना है, आफ्टर दैट उसको जिप करना है एंड देन उसको ईमेल आईडी भेज देनी, किसी पर्टिकुलर ईमेल पे भेज देना। ओके, तो दिस इज द टास्क दैट इज अ कंसिस्ट ऑफ सीरीज ऑफ टास्क एंड यू नीड टू मेक इट ऑटोमेशन। अब कैसे इसको करेंगे, तो उससे पहले हमने एक इंटरफेस बना दिया कि भाई दिस इज द इंटरफेस, जो आपको हमने वेब डेवलपमेंट वाले पार्ट में भी बोला था कि कीवर्ड डालो, इमेजेस डालो, देन सबमिट इट। अब इसका मुझे कोई इंप्लीमेंटेशन करना है, तो किस तरीके से मैं काम करूंगा। तो लेट्स सपोज you created one file जिसका नाम आपने रखा automate.py, ठीक है, एंड गूगल से इमेजेस डाउनलोड करने के लिए यू ऑलरेडी राइट अ प्रोग्राम जिसका नाम रखा डाउनलोड गूगल images.py, ठीक है, तो ये आपके लिए डाउनलोड करके रख लेता है एक फोल्डर में, उसको कॉल करने के लिए क्या पाइथन, ठीक है, तो वो आपकी इमेजेस डाउनलोड हो गई है। देन आपका मैटलैब का प्रोग्राम है, अब वो मैटलैब का प्रोग्राम आपके इमेजेस को रिसाइज कर रहा है। सिमिलरली आपने एक और प्रोग्राम बनाया है जो उसको कन्वर्ट ग्रे स्केल कर रहा है। देन यू राइट अ जावा प्रोग्राम जो आपके फाइल को जिप कर रहा है। देन अगेन यू राइट अ प्रोग्राम जो उस फाइल को ईमेल कर रहा है। तो क्लास बाय डूइंग दिस सीरीज ऑफ एप्लीकेशंस, ठीक है, आपका ये पूरा मॉड्यूलर अप्रोच यूज हो गया है। ओके, नाउ द बेस्ट पार्ट इज दैट लेट्स सपोज मैंने आपसे बोला कि भाई रीसाइज नहीं करना है, तो इसको कमेंट आउट कर दो आप। डाउनलोड हुई, देन वो ऑटोमेटिकली ग्रे स्केल में कन्वर्ट हो गया, देन आगे की प्रोसेस फॉलो हो गई है। ओके, तो दिस इज वन ऑफ द मॉड्यूलर अप्रोच कि मैंने अपने किसी टास्क को डिफरेंट डिफरेंट मॉड्यूल्स में डिवाइड किया एंड सबको एक मर्ज करके एक सिंगल फाइल बना दी मैंने। तो क्लास आई होप ये सभी को ऑटोमेशन थोड़ा सा समझ में आया है, ठीक है। नेक्स्ट, अब मान के चलो कोई इमेज प्रोसेसिंग का कोई टास्क मुझे परफॉर्म करना है, तो सबसे पहले यू राइट अ प्रोग्राम इन मैटलैब, आपने उसको रीड किया, एक्सट्रैक्ट किया, फीचर निकाले एंड यू राइट इन अ फाइल। मैटलैब के प्रोग्राम ने क्या काम किया, फाइलों को रीड किया एंड उसका एक आउटकम एक फाइल में डाल दिया। तो दैट फाइल कैन बी अ CSV फाइल। अब आपने क्या काम किया, यू क्रिएटेड अ प्रोग्राम इन आर। अब वो जो मैटलैब ने फाइल बनाई थी उसको रीड किया, उसका एक मशीन लर्निंग का मॉडल बिल्ड कर दिया एंड जो मॉडल बना है उसको जो आउटपुट आया है उसको एक फाइल 2 में स्टोर कर दिया। एंड देन आई क्रिएटेड अनदर प्रोग्राम इन पाइथन। वो जो फाइल 2 को उसने यूज किया, प्लॉट किया एंड जो रिजल्ट आया उसने फाइल 3 में सेव कर दिया। तो क्लास दिस इज वेरी वेरी इंपॉर्टेंट फॉर यू कि एक दूसरी लैंग्वेज में लिखे हुए प्रोग्राम को कैसे कॉल करना है। ओके, बिकॉज नाउ डेज एवरीथिंग इज अवेलेबल, you need to just make the connection and make the product. Okay, so this is one of the example. अब let's suppose मशीन लर्निंग की जो पाइपलाइन है, ठीक है, तो वो हम जैसे हमने पाई कैरेट यूज किया हुआ है, तो पाई कैरेट में क्या है, पहले डेटा प्री प्रोसेसिंग का पार्ट है। तो लेट्स सपोज अगर मैं उसको खुद इंप्लीमेंट करने जाता, देन पहला प्रोग्राम भाई फाइल को रीड करने का प्रोग्राम बनाया, देन आई क्रिएटेड अनदर प्रोग्राम जो उस फाइल में से डुप्लीकेट को रिमूव करे, नेक्स्ट प्रोग्राम जो आउटलायर को रिमूव करे, देन नेक्स्ट प्रोग्राम जो मेरी मिसिंग वैल्यूज को रिमूव करे, देन सिमिलरली फीचर सिलेक्शन करे। तो इतने सारे टाइप के प्रोग्राम मुझे बनाने पड़ेंगे। बट द बेस्ट पार्ट इज दैट लेट्स सपोज आई डोंट वांट टू हैंडल द मिसिंग वैल्यूज, तो यहाँ पे उसको हैश कर दीजिए। एंड सिमिलरली अब मेरा पाइथन का प्रोग्राम है, उसमें रैंडम फॉरेस्ट का प्रोग्राम बना हुआ है, उसको कॉल किया मैंने, डिसीजन ट्री को किया, सपोर्ट वेक्टर को किया एंड मर्ज ऑल द रिजल्ट। क्लास यू कैन आल्सो क्रिएट योर खुद का पाई कैरेट, आप खुद यहाँ का बना सकते हैं इस तरीके से। सिमिलरली टेक वन मोर एग्जांपल, मैशअप। You need to download 20 videos of Shaggy Man or any other singer. YouTube से आपको 20 videos download करनी है, convert all the videos to audio, cut first 30 seconds audio from all the files, merge all the audios to make a single file. Mashup सभी को मालूम है, छोटे छोटे हमारे audios होते हैं, then zip करना है, email करना, and for every part there are packages available on pypy.org. So class, this is the input, this is the interface that you need to develop. कि सिंगर का नाम लिखा, नंबर ऑफ ऑडियोज कितने मुझे डाउनलोड करने हैं, वो हर एक ऑडियो में से कितने फर्स्ट सेकंड का मुझे कट करना है वो यहाँ पे डिफाइन कर दिया। एंड फाइनली जो मेरा मैशअप बनेगा वो किस ईमेल आईडी पे चला जाए। ओके, सो नाउ लेट्स सपोज जस्ट एक्सप्लोर द pypy.org। ओपन करिए आप भी, just open pypy.org and write down download YouTube video. Just open pypy.org, download audio videos. you will find a long list of packages are available. अब सभी को explore करिए, find out करो जिसकी manual given है, तभी you can then only you can use that particular library. Otherwise manual नहीं है तो you can't use. तो find out कि कौन सा आपके लिए suit कर रहा है. Similarly video download हो गई है. अब आप just लिखिए, write down video to audio. Convert video to audio. Press enter. You will find again long list of packages are available. So in that case, package find out karo, library ko install karo, and just integrate and make the complete pipeline. Okay. So class, this is all about the simulation part, and I hope ये सभी को समझ में आया है. So if you have any question, query, you may ask, please.